Okay, section 2.5, reason using properties from algebra, part 2. We have more properties to review. And again, we're learning all these so that we can do proofs as this chapter continues. So they're actually extremely important that you understand them. The first of all is the reflexive property of equality. And for real numbers, it just says for any real number A equals A. Yes, that property just says that A equals A. So segment lengths. For any segment AB equals AB. And when we talk about segment lengths, there is no line over the top. When we name a segment, we put a little line over the top. When we talk about the length of the segment, there is no line over the top. That's a review from chapter 1. Angle measure. For any angle, let's actually write that out. For any, angle A, the measure of angle A equals the measure of angle A. Nothing too earth-shattering there. Okay, symmetric properties of equalities. For real numbers, so for any real numbers A and B, if A equals B, then by golly, B is going to equal A. Okay? Same thing for segment length. So for any segments AB, let's actually write it out, and CD, if AB equals CD, then gosh darn it, oh goodness, if I could write it correctly, CD is going to equal AB. Okay, so if AB equals CD, then CD is going to equal AB. And guess what? It's the same for angle measures. So for any angles A and B, if the measure of angle A equals the measure of angle B, then, well, I guess the measure of angle B is going to equal the measure of angle A. Rocket science, right? Okay, one more set, the transitive property of equality. For some reason, I've always been able to remember transitive by thinking of trains. Trains go up and down a track, and they travel up and down a track. And for some reason, that's been able to get the transitive property in my mind. Hopefully it works for you. If not, maybe we'll come up with a different trick. So, for any real numbers A, B, and C, if A equals B and B equals C, then A equals C. And I don't know why that makes sense, but I figure like if a train's going on a track and A goes to B and then B goes to C, well then A can go to C too. Yeah, I hope it works for you. We'll try to come up with another trick to remember these, but that one's always worked for me. All right, segment length for any segments AB, CD, and EF, if AB equals CD and CD equals EF, then AB is going to equal E, oh goodness, EF. Okay, that's sort of like the law syllogism, isn't it? Okay, if P then Q, then Q then R, then P then R. But it's the transitive property of equality because trains go from A to B, AB to CD, and CD to EF. So then they're going to go from AB to EF. I don't know. Okay, angle measure. For any angles A, B, and C, if the measure of angle A equals the measure of angle B, and the measure of angle B, that's an angle, let me erase that, get that a little better. Measure of angle B equals the measure of angle C, then the measure of angle A equals the measure of angle C. All right, there's only 6 more slides. We don't have that many examples over all of this information, but that's all right. All right, we are going to work through our first proof. So you all need to slow down, think through this, and proofs take practice, okay? Lots of practice. So we're going to use the information given and determine whether measure of angle EBA, which is right here, EBA is equal to the measure of angle DBC. Okay, and we're going to use the information given to figure this out. So I'm going to have an equation column, okay, an explanation column, and a reason column, just like the last few we've done. All right, first I'm going to see if there's anything in that diagram that's given. And it looks like these little arcs here are given. So I'm going to write that down because we're going to need that. So I have the measure of angle 1 is equal to the measure of angle 3. Okay, the explanation is it's marked in the diagram. And we love this reason. First one is always given. All right, what else? Well, I've got angles here. It looks like this red angle, which is the first one we're trying to solve for, okay, is actually the measure of angle 2 plus the measure of angle 3. So I can say that the measure of angle EBA equals the measure of angle 2 plus the measure of angle 3. Explanation is we're adding adjacent angles, and that is our angle addition postulate that we learned in the first chapter. Yes, we do need this information, which is what I told you guys last week. Angle addition postulate. Okay, we also know that the measure of angle DBC equals the measure of angle 2 plus the measure of angle 1. Okay, same explanation, same reason. Okay, now let's look at what we have. We know that the measure of angle EBA is angle 2 plus angle 3. Angle 2 plus angle 3. The measure of angle DBC is angle 2 plus angle 1. 2 plus 1. And we know that 1 is equal to 3. Okay, well, these match and these almost match because they're up here. I can use substitution to get this side of the equal sign the same for both of them. Okay, so let's do that. I'm going to rewrite the measure of angle EBA is the measure of angle 2 plus the measure of angle 1. because 1 and 3 are the same, so I'm substituting the measure of angle 3 with the measure of angle 1. Okay? It's almost like magic. So I'm substituting the measure of angle 1 for the measure of angle 3. And my reason is the substitution property of equality. Okay, now if we look, let me get a different color in here somehow. I have the measure of angle EBA is measure of angle 2 plus measure of angle 1. The measure of angle DBC is the measure of angle 2 plus the measure of angle 1. So I can say that the measure of angle DBC is equal to the measure of angle EBA because of that transitive property. Okay, and we're done. I know that was hard. We'll do more. Give it a minute. And look, I left more space for myself. I should have used that. That got a little crowded there at the end. All right, in the diagram, segment length AB is equal to segment length CD. Show that segment length AC is equal to segment length BD. Let's write our equation, our explanation, and our reason. And the first thing we write is what's given. Segment length AB is equal to segment length CD because it's marked in the diagram. Can't spell. And the reason is given. Okay, what else do we know? We learned in chapter 1 that segment length AC is equal to AB plus BC. Okay, we're adding adjacent segments, and it's the segment addition postulate. We also know that segment length BD is equal to BC plus CD. Same explanation, same reason. I'm going to go back up to this first line and do a little bit of magic with math. All right, AB plus BC equals CD plus BC. All I did was add BC to each side. And that is our addition property of equality. Okay, nothing too big. But now we see that AB plus BC is equal to CD plus BC. I can now substitute AC equals BD. Okay, it's the substitution property of equality. Okay, I substituted AC equals AB plus BC and BC equals CD plus BC. Okay, let's try another one. Oh, I left another page. That would have been nice to know too. All right, you try. Name the property of equality for the statement illustrates. Name the property of equality the statement illustrates. If the measure of angle 6 equals the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. Okay? I'll pause in a second. Okay, the next one. If JK equals KL and KL equals 12, then JK equals 12. Push pause and write down your own answer, then check them. symmetric property of equality and the transitive property of equality. Last one, measure of angle W equals a measure of angle W. Push pause and write down your own answer. Reflexive property of equality. Okay, that's an E. That's all I got for today. Good job.